Hi guys, so today I'm going to be doing my final lesson presentation for our Math for Teachers 2 class. So let's get started with question 1. Sorry, this slide looks kind of funky, but for question 1, we are asked to draw a graph for 4 different scenarios and explain why our graph corresponds with the scenario. The first graph, right here, correlates to the function of the amount of gas in a gas tank when a driver refills the tank on a drive across the country. As you can see, X is increasing, which means Y is decreasing, which means the further he drives, the more gas he uses, as you can see. When Y is increasing and X is staying the same, that represents the tank being filled up. Now let's go to graph B. So for B, I drew a graph that correlates to the function of the height of an elevator stopping at each floor on its way up. So Y increasing represents the elevator going to the next floor, and then when Y is staying the same and X starts to increase, that represents the elevator stopping on the next floor. And as you can see, it goes up and stops and up and stops. So the next one, for graph C, I drew a graph that represents the function of the length of a shadow of a flagpole throughout a sunny day. And as you can see, as the day goes on, the length of the graph, or the length of the shadow, gets shorter, and then when the sun goes down, the shadow gets longer, as you can see. And now we have graph D, bouncy ball height and the time that ball bounces. So for D, I drew a graph to correlate with the function of the height of a bouncy ball dropped from a table. You can see that the arches get shorter as the ball keeps bouncing after it is being dropped from the table. Now let's go to question 2. So for question 2, Myra cuts out a regular pentagon, hexagon, and an octagon, and it seems to her that they form a vertex figure, such as the one shown below. Is Maya correct? Well, let's look at our figure. So here's our octagon, hexagon, and our pentagon. So the first thing that we have to know is that the measure of the interior angles meeting in a vertex must add up to 360. So for our octagon, our interior angles are 135 degrees, and for our hexagon, they are 120 degrees, and for our pentagon, they are 108 degrees. So we must add up all 3 of these interior angle degrees and see if they add up to 360. So as you see, 108 plus 135 plus 120 equals 363. So that means that it is not a vertex figure because it is 3 numbers past 363. So for Maya to turn this into a vertex figure, we must put a 3-degree gap in between the pentagon and the hexagon. Now let's go to question 3. So for question 3, we have to find the area and the perimeter of these triangles. So to find the area of a triangle, we have to know the formula. And the formula for an area of a triangle is area equals 1/2 base times height. So let's get started. So for triangle A, our base is 82.3 meters, and our altitude, or our height, is 48.0 meters. So we plug these numbers into our equation. 1/2 82.3 times 48.0, which equals 1,687.15 meters. And then to find the area or the perimeter of a triangle, all we have to do is add up the three sides together. So our perimeter is 199.3 after we add up our sides, 48.0, 69.0, and 82.3. Let's go to B. So for B, our base is 88.8, and our height is 37.0. So we plug in our numbers into our equation. 1/2 88.8 times 37.0, and this equals 1,642.8 inches. And then for our perimeter, we add up all of our sides, 88.8 plus 37.0 plus 96.2, which comes out to be 222. Now let's go to our last triangle. So our base is 6.2 centimeters, our height is 2.6 centimeters, and we plug these up into our equation. 1/2 6.2 times 2.6, which comes out to be 8.06 centimeters. And our perimeter, 8.5 plus 6.2 plus 3.1 equals 17.8 centimeters is our perimeter. Now let's go to question 4. So for question 4, we have to graph 3 functions and show their similarities, differences, and relationships between the graphs. So let's look at our first one. So we have x and y equals x2. And the first thing I did was create a table of values and plug in numbers -2 through +2 for x. And after plugging the numbers in for x and getting my output y, I use these numbers to plot my points. So for this graph, we get this curve for y equals x2, and then we have our second set, x and y equals x2 plus 7. And after we plot our points, it looks like this. And then our third table of values, we have y equals x2 minus 7. And our graph, or our curve, looks like this. And as you can see, after looking at the graph, all 3 of the graphs are similar because they are vertical shifts of the exact same curve. So y equals x2 minus 7 shifts downward 7 points from y equals x2, and y equals x2 plus 7 shifts up 7 points from y equals x2. So now let's go to question 5. So for question 5, Ephraim and Devontae were asked to reflect the pattern block figure shown on the left over the horizontal line through the center of the square. They rearranged the blocks to form the figure on the right. So here is our figure, and this is after they reflected it over the reflection line. So what type of rigid motion did they use? So Ephraim and Devontae used straight downwards translation of the top block and reflection of the bottom block. How would you help clear up their understanding? So as you can see, something doesn't really look right here. So what is it? So here's our shape. And this is what our shape should look like compared to how it looked like right here. So as you can see, they did not reflect the triangles over the horizontal line, and it should have been inverted like this. Oops. Now let's go to question 6. So for question 6, we have to find the measure of all the angles inside of a concave polygon, like this one right here. So the first thing we have to know is the sum of any n-gon is n minus 2 times 180, n being the number of sides. So as you can see, this polygon has 8 sides. So after we know how many sides there are, we have to substitute the value of n into the expression n minus 2 times 180. So we would put n minus 2 times 180, which comes out to be 1,180. And after this, we have to set the sum of the measures of the interior angles equal to the value of the sum of the interior angles and solve for y. So we have to add up all of these and set them equal to 1,180, which comes out to be 54y equals 1,080, and y comes out to be 20 degrees. And after this, we plug in 20 degrees into each of our equations. So 3y equals 3 times 20, which equals 60 degrees. 7 times 20 equals 140. And 12 times 20 equals 240. So our interior angles equal 60 degrees, 140, and 240. Now let's go to question 7. So for question 7, we have to figure out, for part A, which shapes have one line of symmetry but no rotational symmetry. So let's look at our shapes right here. So the diamond has one line of symmetry because it can be folded over the line of symmetry, and it will look exactly the same as the bottom half if the top half is folded over. The next shape that has one line of symmetry is the triangle, for the same reason the diamond has one line of symmetry. It can be folded over the line and it will match exactly. The half circle also has one line of symmetry. The rectangle, this triangle, and the hexagon. For part B, we have to find shapes that have rotational symmetry but no reflection symmetry. So for a shape to have rotational symmetry, it can be rotated 180 degrees and look exactly the same. But if it doesn't look exactly the same, then it does not have rotational symmetry. So this shape has rotational symmetry because it can be rotated 180 degrees and look exactly the same, but it does not have reflection symmetry. This shape also has rotational symmetry because it can be rotated 180 degrees and look exactly the same. For C, we have to find shapes that have reflection and rotational symmetry. The rectangle has one line of symmetry, and it can be rotated 180 degrees and look exactly the same. The diamond has one line of symmetry and can be rotated and look exactly the same. And the hexagon can be rotated 180 degrees and has one line of symmetry and look exactly the same. Now let's go to question 8. So which is larger, the area of the region between the circles or the area inside of the smaller circle? Now let's look. So we have our figure right here. And since the side lengths of the square are 10 units, the diameter of the circle must also equal 10 units, which means our radius is 5 units because our radius is half of the diameter and 10 divided by 2 is 5. So the first thing we have to know is the equation for the area of a circle. The equation for an area of a circle is pi times radius squared. So the area of the small circle would be pi times 5 squared, which equals 25 pi units squared. Now the area of the larger circle, we have to do a squared plus b squared equals r squared. So we would do 5 squared plus 5 squared equals r squared, which equals 50 equals r squared and comes out to be 50 pi units squared. 50 minus 25 is 25, so it comes out to be 25 pi units squared. So this means that, the area of the region between the circles and the area inside of the smaller circle are actually exactly the same. They are not larger and they are not smaller. So for question 9, we have to show and explain the slopes of the line segments determined by the given pairs of points. In each case, we have to tell whether the segment is vertical, horizontal, slopes upward to the right, or slopes downward to the right. So first we have to know what point slope formula is, and slope formula is y2 minus y1 over x2 minus x1, and we get these y and x values from the points that are given to us in our problem. So let's start with part A. So we have pairs 3, 1, and 5 and 5. So we would put these into our slope formula. 5 minus 1 over 5 minus 3, which is equal to 4 over 2, which is equal to 2. So our slope is 2. And our line segment slopes upward to the right. And another way that we can check to see if our slope is correct is to do the rise over run method, and we would put a 1 underneath our 2, so 2 over 1, and we count down to 1, 2, and then over 1, and 1, 2, and over 1. So we have calculated our slope correctly. And we do the same things for parts B and C. So for part B, we have pairs 5 and 8, and then 5 and negative 8, and we put these into slope formula. Negative 8 minus 8 over 5 minus 8 equals 16 over 0, and anything divided by 0 is 0, so that means our slope is 0. And if our slope is 0, that means that the line segment is going to be vertical because we do not have a slope. And for C, we have negative 1 and negative 4, negative 4, and negative 13. So we would do negative 13 minus negative 4 over negative 4 minus negative 1, which equals negative 9 over 3, which is 3. So our slope is 3. And our slope would be upward and to the right, as you can see. So now let's go to question 10. So for question 10, we have to figure out the interior, exterior, and central angles of our polygon we have here. And to do this, we have to know our formulas for each of the angles. So our interior angles have a measure of n minus 2 times 180 divided by n, and our exterior angles have a measure of 360 divided by n, and our central angles also have a measure of 360 divided by n. So n is actually equal to the number of sides of our polygon, and if you count, we have 9 sides. So we have to substitute n into the formula, or substitute 9 into the formulas for each types of angles. So let's get started with our interior angle. So after substituting 9 in, we have 9 minus 2 times 180 over 9, which is equal to 140. Next, we substitute 9 into the formula for our exterior angle. So after substituting, we have 360 over 9, which is equal to 40, and the same goes for our central angles. So now our interior angle is equal to 140 degrees, our exterior angle is 40 degrees, and our central angle is also 40 degrees. Now let's go to question 11. So for question 11, a regular pentagon, penta, and an equilateral triangle, PQR, are both inscribed in the same circle centered at O with P a common vertex. So the first thing we are going to do is form this figure and find the measurement of NOQ. So here we have our pentagon and our circle, and then we have our triangle, and now we are going to form our angle. And as you can see that another triangle can actually be created, QOP or PQO, however you want to say it. And we can put this over here, and we know that a triangle is equal to 180 degrees, so we can go ahead and give this triangle its measurements, 30 degrees for our acute angles, and 120 for our obtuse angle, and we are going to use this later. And next we are going to find our measurements for our pentagon. And the reason we have to do this is because our blue triangle and NOQ are touching 2 points of our pentagon. So let's find the measurements. So we would do 5x equals 360, and we would do 360 divided by 5, which is 72. So our angles in our pentagon are equal to 72 degrees. So we would put 72 right here for this angle and right here for this angle, which equals 144. And then next we would do 144 for this angle right here minus 120, which is our obtuse angle in the triangle that we made, to figure out our angle in OQ, which is 24 degrees. So our angle is 24 degrees. Now let's go to question 12. How many mouthfuls are in a gill, cup, and a pint? Well, let's look at our measurements first. So we have a pail is equal to 2 gallons, 1 gallon is equal to 2 bottles, 1 bottle is equal to 2 quarts, 1 quart is equal to 2 pints, 1 pint is equal to 2 cups, 1 cup is equal to 2 gills, and 1 gill is equal to 2 jacks, 1 jack is equal to 2 jiggers. Now let's figure out how many mouthfuls are in a gill, cup, and a pint. So this is like a doubling system. We know that 1 jigger is equal to 2 mouthfuls. And if we double the amount of mouthfuls, 2, we would get 2 jiggers is equal to 4 mouthfuls, which actually equals 1 jack. And 2 jacks is equal to 8 mouthfuls, which equals 1 gill. Now we can figure out how many mouthfuls are in a cup. 2 gills is equal to 16 mouthfuls, which is equal to 1 cup. And next we find out how many mouthfuls are in a pint. 2 cups equals 32 mouthfuls, which equals 1 pint. We just keep doubling the amount of mouthfuls to find our answers. Now let's go to question 13. By holding a ruler 2 feet in front of her eyes, as illustrated in the diagram, Jenny sees that the top and bottom points of vertical cliff face line up with marks separated by 1.5. Jenny is about a quarter mile from the cliff. What is the approximate height of the cliff? Recall that a mile is 5,280 feet. So the first thing we are going to do is see how this relates to triangles, how it is similar. So if we put 1 triangle here and 1 triangle right here and name the big one A, B, C, and the little one D, E, and F, we can see that D is congruent to A, angle E is congruent to B, and angle C is congruent to F. So this is how triangles are similar to this problem. So next, let's get started. So by we can remember that 1 mile is equal to 5,280 feet, but Jenny is actually standing a quarter of a mile away. So we would need to divide 5,280 by 4, which equals 1,320 feet. Also, our ruler is 1.5 inches, and we need to convert that into feet, which is 0.125 feet. Now we can get started with our math. So we have 2 feet over 1,320 feet, and then we have 0.125, our ruler, over cliff. And now we can cross multiply, so our cliff equals 0.125 times 1,320 over 2, which is equal to 82.5. And 82.5 is the height of our cliff. Now let's go to question 14. So for question 14, we have to show that the ratio of the volumes of the cone to the sphere to the cylinder is 1 to 2 to 3. So first we have to know the formulas of the volumes for each of these shapes. So the volume of a cone is 1 over 3 base times height, and to find our base of a circular cone, we have to do pi times radius squared. And we know that our height is 2r, so if we plug that in, we get our new formula, 2 over 3 pi radius cubed. Next, we have the volume of a sphere, which is volume equals 4 over 3 pi radius squared. And then next, we have the volume of our cylinder, which is base times height, and the base of a circular cylinder, to find that, we do pi radius squared. We know that our height is 2r, so if we plug these into our equation, our new formula is 2 pi radius cubed. So in order to see if the volumes of the cone to the sphere to the cylinder is 1 to 2 to 3, we have to find the area of the cone to the sphere, or the cone, sphere, and cylinder. Now, in order to do that, we have to divide each of these formulas by the volume of our cone. So let's start with the cone. So this is pretty simple because we are just dividing 2 over 3 over 2 over 3, which is equal to 1. And now we would do the volume of our sphere divided by the volume of our cone, which is 4 over 3 pi radius squared over 2 over 3 pi radius cubed, which is equal to 2. And then we would do the volume of a cylinder divided by the volume of the cone, which is 2 pi radius cubed over 2 over 3 pi radius cubed, which is equal to 3. So this is how you prove that the ratios are 1 to 2 to 3. Now let's go to question 15. So for question 15, we have to demonstrate how to find the measures of angles 1 through 8. So we see that angles 1C and B make up the triangle, and a triangle is equal to 180 degrees. So angle 1 plus angle C plus B are equal to 180 degrees. So since we already know angle C is 74 degrees and angle B is 26 degrees, we know that angle 1 plus 74 plus 26 is equal to 180. So angle 1 must be equal to 80 degrees. We then know that angles 3 and 8 correspond to angle 1, so that means that they are the same. And first we can extend the parallel lines to find corresponding angles. And therefore angles 3 and 8 are also 80 degrees. Next, we have angle 2 plus angle 3 equal 180, and angle 2 plus 80 degrees is equal to 180, which means that angle 2 is equal to 100 degrees. Negative 5 and angle 3 are alternate interior angles. So angle 5 is congruent to 1, 3, and 8. Therefore, 5 is equal to 80 degrees also. Angle 7 and angle 8 are supplementary angles, and both 7 and 2 are supplementary to angle 5. So that means angle 7 is the same as angle 2, which means that angle 7 is also equal to 180 degrees. Angles 4 and B are corresponding angles, so angle 4 is equal to angle B, which is 26 degrees. Angle 6 and C are also corresponding angles, so angle 6 is equal to angle C, and angle C is equal to 74 degrees, so angle 6 is also 74 degrees. Now we have question 16. So for question 16, we have to look at the triangles QPT and SPT for part A, and we can see that line PT is acting as a line of reflection, and if we were to fold this figure in half vertically, it would meet perfectly, which means that these triangles are exactly the same or congruent. And for part B, we have to demonstrate why angles QPT and SPT are true. And we could use this same logic. QPT and SPT are congruent. If we folded those angles together, they would be exactly the same. And for part C, we have to demonstrate why triangles QPV and SPV are true. So let's look at them. So here we have the two smaller triangles. If we were to fold QPV over, it would fit exactly on top of triangle SPV because they are the same shape and size. They are congruent. And that also helps us explain why angle QPV is a right angle. That right triangle fits perfectly there next to SPV. And SPV is also has a right angle right here. And now let's go to question 17. So for question 17, we have to construct a cube with vertices A, B, C, D, E, F, G, and H. So for part A, in a different color, we have to construct vertices D, E, G, and H, which are the vertices of a tetrahedron inscribed into the cube. A tetrahedron is a solid having four plane triangular faces, which is actually a triangular prism. So let's construct our shape. So right here, we have our triangular prism. Now for part B, we have to construct three of the faces of the tetrahedron DEGH as subsets of the faces of the cube, which means that the tetrahedron inscribed in the cube has none of its faces in the planes of the faces of the cube. So for part B, we have to make sure that none of the faces in the planes of the faces of the cube. So here is part B. And this is what it would look like. Now let's go to question 18. So suppose two function machines are hooked up in a sequence. So the output chute of machine G empties into the input hopper of machine F. So we are using function machines, and there are rules that the function machine has that we have to follow. So let's look at those rules. So if you look at this, you see that our rules are we have to multiply by 3 and then add by 8. So that means we have to input x into our function and to get our output y. So for example, in part A, we have to input 0 into our function. So we would do 3 times 0, which is equal to 0. And then we would put 0 into our g of f function. So we would do 0 plus 8, which is equal to 8. And then for part B, we input 1. So 3 times 1 is 3. And then we input 3, or we input 1 into our g of f function, which is 3 times 1 plus 8, which is equal to 11. And for part C, we input 2 into our function. So 3 times 2 is equal to 6. And then we input 2 in our g of f function. We get 3 times 2 plus 8, which is equal to 14. And then for D, we input 3 into our function. So we would do 3 times 3 equals 9. And then we input 3 into our g of f function. 3 times 3 plus 8 equals 17. Thank you, guys.